Everybody, Mr. Barry here. We're going to be in the second unit. We're talking about quadratic functions and specifically the three different types that we could get and use to pick out certain situations and certain pieces of information. And we're talking about intercept form in this video and in this nearpod. So I have y is equal to -2 times quantity x minus 1 times quantity x minus 5. We're just going to go run through this. We're going to go ahead and graph this function as well. And we want to make sure that when we see something in intercept form, the very first thing we do, as it says in the actual wording, there is figure out what the x-intercepts would be, the x-intercepts. So I'm going to come over here to this function, and I see inside the parentheses here, wherever I find that variable x, I want to figure out, just like we did with the absolute value last unit, I want to figure out what values of x would give me a 0 inside of those parentheses. So here, I have x minus 1. What would give me 0 if I had that right there? Now maybe you'd be able to go ahead and just take a look at this without doing this math work, but just because I can figure out that if I have x is equal to 1, if I took the number 1 and I plugged it in, that parentheses right there would be 0. I'd have to multiply everything times the 0, and it would become 0. It's kind of one of the reasons why we actually sometimes call these points right here zeros, because the y value would be 0. The other one over here, excuse me, is x minus 5. Again, I'm trying to figure out what value for x would I be able to plug in to this parenthesis in order to get a value of 0. And when I do the math work there, I would be able to plug in 5. Again, you could probably just take a look up here. 5 minus 5 would be 0. So again, another one of my x-intercepts would be 5, 0. So I'll graph those points over here on the graph. We have a point at 1, 0. We have a point at 2, 3, 4, 5, 0 right there. That's our x-intercepts for this problem. The next thing up that I need to figure out here, because again our goal for graphing a parabola is to have at least 5 points. The next one up, probably the easiest thing to do, is to calculate the axis of symmetry. So next up is the axis of symmetry. To do this two ways. Mathematically speaking, we're going to add up the 1 and the 5 and divide it by 2, or if you have a picture like this, you could pretty much just kind of look and see what x value would be in between 1 and 5. Either way, let me just go ahead and show you what's going on here. So I got 1 plus 5. I'm going to divide that by 2. 1 plus 5 is 6. 6 divided by 2 would be 3. So we're doing the axis symmetry here because we're in the process of trying to find the vertex. The first part of that is to get the axis of symmetry. So in this problem, our axis of symmetry will be x is equal to 3. So that axis of symmetry acts as our mirror. I can go ahead and put a dotted line. Straight up x is equal to 3. But I still need to find the y value for the vertex. So obviously the x value is 3, but I need to find the y value for the vertex. I got to take that 3, I got to go plug it back into the original function that was in intercept form. So let me go ahead and rewrite it. I'm going to put 3 in wherever I see an x. There's once that it appears. There's another time that the x value appears, so I got to plug them in both times. I'm doing some math work here. 3 minus 1 is 2. 3 minus 5 is -2. I have the -2. There's a whole lot of 2's in this problem. There's a -2 already out in the front. That's our a value here for the original problem. So -2 times 2 is -4. -4 times -2 would be +8. So for my vertex, I have a 3 for the x value. My y value would be 8. So what I'll do is I'll come over here. I'll find the point 3, 8. 1, 2, 3 for the x value. I got to go up 8. 2, 4, 6, 8. Right there would be my point for the vertex 3, 8. Now maybe you saw this a value in the front here, -2, right from the get-go. Maybe you're kind of realizing now that in this scenario right here, this vertex will be a maximum. Again, our a value is negative, the u is going to be going down for the parabola. The final thing I need to do here is I need 2 more points to graph this, make sure this is the best looking graph we can come up with. I want to go ahead and try to figure out if there are any y-intercepts. So we early on figured out x-intercepts. Now I want to go ahead and figure out if there's any y-intercepts. So maybe I'll scroll over here a little bit with our camera, and we'll come off to the side over here, and we'll need to figure out some y-intercepts. So our y-intercept here, we know that our y-intercept, our x value would be 0. So for x-intercepts, we have y values that are 0. The flip-flop that happens here. So I'm going to go ahead and I'm going to take x, I'm going to make it equal to 0. I'm going to figure out what happens when x is equal to 0. Let me plug it into the original function. And again, wherever I see an x, I'll plug in the number 0. Do some math work here. 0 minus 1 is -1. 0 minus 5 is -5. Certainly no shame in using a calculator in this. -2 times -1 is +2. +2 times -5 would be -10. So our y-intercept here would be the point 0, -10. I'll come over here to our graph and I'll plot that point. I'm going to go a little bit kind of further down. Let's go here at 0, so we don't move left or right at all. 2, -4, -6, -8, and -10 is right there. That's 4 points. We're almost there. The last point I need to figure out, and I'm going to use the y-intercept for this, is I'm going to use the y-intercept and the mirror. So very quickly, I'm going to write a table of values. We're going to put our vertex in the middle, and our vertex was 3, 8. I had our 2 points that were y-intercepts at 1, 0, and 5, 0, and then finally I just figured out a point 0, -10. So I want to figure out what goes down here as my last point, and I need to think about how the mirror works. If 3, 8 is our vertex, 0 is 3 spots away from the number 3. What would be 3 spots away going off in this direction? And hopefully you realize that if you tack on 3 more, that would be 6. The x value of 6 should have the same exact value for y because of the mirror action. So again, 0, our vertex is 3, 8. Our x value here is 0, is 3 spots away from the vertex. 3 spots away from the vertex on the other side of the mirror would be 6. They should have the same exact y values, just like our 1 and 5 had the same exact x values. So I'm going to come over here to 6. I'll go all the way down to -10. Now I have 5 points on the graph. I'm going to do my very best here to connect the dots, but hopefully you can kind of see that there's certainly 5 points here. There we go. There we go right there. Thank goodness it's not an art class, but there you can see the parabola. So what we have there, again, just to wrap it up, is we figured out our x-intercepts first. Here in this problem we had 2 of them. Then we were able to calculate the vertex, first finding the axis symmetry, the x value in between those 2 x-intercepts, and then plugging that back in. Then I could go ahead and figure out the y-intercept. I plugged 0 in for x and found a y for that. The 5th point came from using the concept of the mirror and knowing that we had the same exact y value on the other side. And you could always go back and check your work on that point right there, but it does hold true because of the mirror.